Hello students, welcome to second session of number theory. This is the second session of unit 1. In this session we study about divisors, greatest common divisor GCD and relatively prime numbers. Definition of divisors. An integer b is said to be divisible by an integer a non-zero in symbol a divides b if there exists some integer c such that b equal to the product ac. We write a does not divide b to indicate that a does not divide b. Different expressions of divisors. First one, A divides B implies A is a divisor of B. Second one, A divides B implies A is a factor of B. Third one, A divides B implies B is a multiple of A. Now we have a note. If A is a divisor of B, then minus A is also a divisor of B. Now examples, 4 divides 12 because we can write 12 equal to 4 into 3. Here 3 also divides 12. 4 divides minus 16 because minus 16 equal to 4 times minus 4. Here minus 4 also divides minus 16. 3 does not divide 10 since there is no integer case such that 10 can be written as 3 times an integer. Here minus 3 also does not divide 10. Theorem. For integers a, b, c, the following hold. A divides 0, 1 divides a and a divides a. That is, any integer a divides 0, 1 divides all the integers and any integer a divides itself. Second one, a divides 1 if and only if a equal to plus or minus 1. That means 1 divides 1 and minus 1 divides 1. C. If a divides b and c divides d, then the product AC divides the product BD. D. If a divides b and b divides c, then a divides c. E. A divides B and B divides A if and only if A equal to plus or minus B. F. If A divides B and B is not equal to 0, then modulus of A less than modulus of B. That means the absolute value of A is always less than absolute value of B if B is negative or positive. G. If A divides B and A divides C, then A divides the linear combination Bx plus Cy for arbitrary integers x and y. Definition of greatest common divisor GCD. Let A and B be given integers with at least one of them different from 0. The GCD of A and B denoted by GCD of AB is the positive integer satisfying the following condition. First one, D divides A and D divides B. That means D divides both A and B. Second one, if C divides A and C divides B, then C divides D or C less than or equal to D. C divides A and C divides B means C is any other common divisor of AB. Then C divides D, that is any other common divisor of A and B divides the greatest common divisor. Examples, GCD of minus 5 and 5 equal to 5 because the only common divisors of minus 5 and 5 are 1 and 5 itself. So 5 is the greatest. GCD of 8 and 13 equal to 1 because only common divisor of the 8 and 13 is 1. GCD of minus 8 minus 36 equal to 4. Here the common divisors of minus 8 and minus 36 are 1, 2 and 4 is the greatest. Relatively prime numbers. Two integers a and b not both 0 are said to be relatively primes if GCD of AB equal to 1. Example, 2 and 9 are relatively prime since GCD of 2, 9 equal to 1. Theorem, let A and B be integers not both 0, then A and B are relatively prime if and only if there exist integers x and y such that 1 equal to ax plus by. In the above example, 2 and 9 are relatively primes, then we can write 1 equal to 2 into 5 plus 9 into minus 1 because 10 minus 9 is 1. Here x equal to 5 and y equal to minus 1. Thank you for listening and watching this video. Thank you all.